So welcome to this is the FMSP online revision session for AQA Statistics S2, and in this session we're going to be looking at the concept of discrete random variables. So clearly we need to know what these are, we need to understand them, and we need to use their probability distributions. We need to be able to find the mean, variance and standard deviation from discrete random variable probability distributions, and we also need to be able to find the mean and variance of simple functions, usually linear, reciprocal, squared, but generally simple functions of discrete random variables as well. So on your formula sheet we're given some information about how to do this. We're given information about how to find the expectation, which is the word that we use for the mean when dealing with a probability distribution, the variance and its associated notations, and also how we manage to deal with functions of random variables as well. This is also, when you look at the work on continuous random variables, there are some similarities between that and this. Okay, so June 2010, question 6. The number of strokes are taken by the members of a Duffers Golf Club to complete the first hole may be modelled by the following discrete probability distribution. So we call this a PDF, effectively, a probability distribution function. It's more of a table, but if we keep thinking about it in this way, it might help a little later on. So what we're asked to do is to determine the probability that a member takes at least 5 strokes to complete the first hole. So here we're looking at the concept that if you were to add all probabilities together, you should get 1. It's always worth just checking that that's true. Here it is, so that's absolutely fine. But each of these outcomes is independent, so it's more of a question of now adding. So taking at least 5 strokes. So what is this? This is the probability that R is greater than and equal to 5. So that's going to be this, 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 and this outcome. So we need some evidence that you're going to be adding. I know it's only worth 1 mark, but it's always a good idea just to do a little bit of working out here. Okay, so that's going to give me 0.7, and you're going to get a B mark for doing that. We're then asked to calculate ER, and what we're told on the formula sheet is that the expectation of R is equal to the sum of R times by P. Now, these are here because they should be, but they're zeros, so we don't need to consider those. So again, some evidence about what you're doing is useful. So 3 times 0.1, you could put it on the table, you could write it as a formula. Either way is absolutely fine. Plus 4 times 0.2, plus 1.5, plus 6 times a quarter, 1.5, plus 0.7, plus 0.4. So anything like that to help us see that you're doing this correctly would be okay. And that's going to give me 5.2. So what do we get? Well, we get a method mark for describing the process by which you get the right answer, and then, as always, your accuracy mark for getting the correct answer. We're then asked to show that the variance is equal to 1.66. So as a reminder, don't forget with show that questions, you have to demonstrate every single step that you're doing. So there's a nice formula that you can remember here, and it's the expectation of the squares minus the square of the expectations. That's by far the easiest way of working out or remembering the variance formulae. So the second half of this we've just worked out. The expectation of R we've already got. Okay, we've just worked that out to be 5.2. So what we need to work out first of all to do this is the expectation of the squares. So all that means is that we're looking at the sum of R squared times by P. So that's going to be 9 times by 0.1 plus 16 times by 0.2 plus 25 times by 0.3 plus 36 times 0.25 plus 49 times by 0.1 plus 64, 8 squared, times by 0.05. So we need some evidence that you're squaring R to do this. Okay, now that's going to give me 28.7. So now we can work out the variance of R. So the variance of R is going to be 28.7 minus 5.2 squared, which if we calculate that through, I'm happy now to give me 1.66. So how are these marked? Okay, well, you're going to get 2 marks. You're going to get a method 1 and an accuracy 1 for working out E of R squared. Okay, you're then going to get M1 for using this variance formula, and then an A1 for the correct answer at the end. So you really need to demonstrate here what's going on. So you can write it as 3 squared, 4 squared, 5 squared, and so on, but you must do something to evidence what you're doing. Okay, so then it gets a bit more interesting. So the number of strokes S taken by the members of Duffer's Golf Club to complete the second hole may be modelled by a slightly different distribution. And we're told that R and S are independent. That's important. Okay, what it means is we can add the discrete random variables together and create a new distribution without any hassle. So we're asked to show that the probability of R plus S is less than or equal to 8 is 0.24. Okay, so to do that, what we need to be looking at is some various probabilities. So we're adding them together. So let's think about this ever so carefully. We've got R. Now the smallest score you can get on R is 3. The smallest score you can get on S is 3. So we are effectively going to start creating a new distribution. Okay, and if you continue reading the questions, we're going to probably need that for part 2 anyway. Okay, we'll see. So let's start considering this. Let's start considering the distribution of R plus S. So to get R plus S, we've got a minimum score of 6 or 7 or 8 and so on. And this goes up to, if we look, it goes up to 16. So we're not going to work all of it, but we're going to work out the ones that we know we're going to need. So what are the probabilities? Well, you've got to get a score of 3 and a score of 3 to get 6. So this is where the independence kicks in. So to get that, it's got to be from R, it's going to be 0.1 times by 0.15. Now to get a score of 7, there's actually 2 ways of doing this. Okay, I'm going to split this off now. So R plus S equals 6 is 0.015. Now, to get 7, there are actually 2 ways of doing this. Okay, it's the probability that R is equal to 3 times by the probability that S is equal to 4 plus the probability that R is equal to 4 times by the probability that S is equal to 3. And again, we can only do this because we're told that they're independent. So this is 0.1 times 0.4 plus 0.2 times 0.15 from the previous table, which gives me 0.07. Then, for the probability of R plus S equals 8, there's a few more selections here. There's 3 in total. Okay, this is worked out by probability of R being 3 times by S being 5, R being 4, S being 4, R being 5, S being 3, sorry. Okay, so if we work these out, that's going to be 0.2 times 0.8 plus 0.4, sorry, I was correct, plus 0.1 times 0.3 plus 0.3 times by 0.15. And again, we would add all of those together, so 0.155. So these are all of the probabilities of being less than or equal to 8. So what we need to do now is to add all of those together, which is going to give me 0.24. And again, because it's a show that question, I do need to see the following piece of information. Okay, so let me change colour so I can show you the mark allocation. So you're going to get the following. You're going to get a B mark for working out this probability. You're going to get another B mark for working out this probability, and you're going to get a third B mark for working out this probability. You then get a method mark for showing me that you've added them together, and an A1 mark for doing that. So if you don't add them together or write down that you've added them together, you're not going to get that method mark, so you're only going to get 3 out of the 5. Okay, so be very, very careful with how you present your work. Okay, so part 2, calculate the probability that when 5 members are chosen at random, at least 4 of them complete the first 2 holes in fewer than 9 strokes. So this is where they're actually pulling another topic in. So they're using the binomial distribution really here to do this, but not really formally. So here we go. We're looking at the probability. So we're choosing 5 members. So we've got 5 and we're choosing 4 of them. And fewer than 9 strokes. Okay, well, what is fewer than 9 strokes? Fewer than 9 strokes is the probability of R plus S being less than or equal to 8. Oh, we've just worked that out. Okay, and that's why they've asked us to show it, so that it's easy to mark. So to do this, 4 of them, so to the power of 4 must succeed, and 1 of them must fail to do this. Okay, or all 5 of them manage to succeed. Okay, so we work these out. This is going to give me 0.0126. You could use tables to do this as well, clearly, but here we go. So 0.0126 plus lots of noughts, 0.000, 796. And again, be very, very careful when copying down from your calculator about getting the correct number of zeros when you do these. Okay, so 3 marks. You get 2 method marks for calculating here. The first one is for the first term correct. The second one is for adding and the second term correct, in terms of the formula anyway. And then an accuracy mark for it correct at the end. We're then asked to calculate the probability of R equaling 4 given that R plus S is less than or equal to 8. So it's a really good idea now, I think, just to go back and look at what we've done. So we had 6, okay? So we had, to get R plus S equaling 6, that was the probability of 3, we'll call this R and S, probability of 3 times the probability of 3. When it was equal to 7, it was probability of 3, probability of 4, probability of 4, probability of 3. When we were looking at 8, it was 3 and 5, 4 and 4, and 5 and 3. And we are now looking for the probability of R equaling 4 given that R plus S is less than or equal to 8. Now, sometimes it's easier not to use formulae here. I will do that in a minute, but we only have 2 outcomes where R is equal to 4. Okay? So, because we've worked all of these out already, we can actually probably save ourselves some hassle. So the probability of it equaling 6 was 0.015 and so on. Now it's these two I'm interested in. So the probability of 4 and then a 3 was 0.2 times 0.15, and the other probability here, a 4 and then a 4, was 0.1 times by 0.3. And it's these two probabilities, so 0.2 times 0.15 plus 0.1 times 0.3, out of the total probability that we're dealing with, which we've worked out to be 0.24. Okay, and that's how the condition is set up, okay, which will give you 0.458. Okay, alternatively, we can set up a formula, but you'll find that it gives us exactly the same setup as we've got here. Okay, so how is this marked? Well, you get a B1 for forming the formula, M1 for getting the correct denominator, that's the quite an important thing, and then you get A1 for getting the correct answer at the end. Okay, so with the next question, June 2011 question 4, they've set up the discrete random variable more as a function than anything else. My piece of advice with this is the first thing to do is to actually consider writing it as a table. So 1, 2, 3, 4, 5. If it's less than 0 or greater than 5, then it's got a 0 probability. And then fill in the table. Always a good idea in my view. Okay, so this is going to give me 3 out of 40, 6 out of 40, 9 out of 40, 12 out of 40, and then 5 out of 20. Okay, well, I'm going to call that 10 out of 40 for obvious reasons. Okay, you should then check that they add up, and they should add up to 40s, which they do, so that's great. Okay, now that's going to help you massively with this question, I promise you. So always think about doing that. Okay, and we're asked to calculate E of x. So the definition of E of x is the sum of x times by the probabilities. So again, we've just created some of this work already. So it's going to be 3 out of 40 plus 2 times 6 out of 40 plus 3 times 9 out of 40 plus, and you can put this on your table, as I say, don't forget you can do that, 4 times 12 over 40 plus 5 times by 10 over 40. And now this just makes adding the fractions a lot easier. Okay, we get 3.5. 2 marks for this. You get a method mark for demonstrating the correct process, and then a method mark for the correct answer. And of course, as I say, you can do this on your table that you've just created to make life a bit easier for you. There's no problems with that. So now we've got to show that question. Okay, this is a function, so e of 1 over x, quite simply, is going to now be the sum of 1 over x times by p. We just replace x for the function in here. So it's going to be reciprocals. So always demonstrate what's going on. So it's going to be 1 over 1 times by 3/40 plus 1 over x, which is 2, times 6 over 40, plus 1 over 3 times by 9 over 40, plus 1 over 4 times by 12 over 40, plus 1 over 5 times by 10 over 40. Okay, and if we add all of those up, we can see that we're going to get 7/20. Okay, so that's quite nice. 2 marks. You get a method mark for demonstration and an A1 for the correct answer. We're then asked to show that the variance, so again, as in the previous question, we need to work out the expectation of the squares. So it's 1 over x all squared. Now again, remember, it's the 1 over x that's being squared, not the probabilities. Okay, so it's going to be 1 over 1 squared times 3/40 plus 1 over 2 squared times by 6 on 40 plus 1 over 3 squared, 1 over 4 squared, and 1 over 5 squared. Okay, and again, what's that going to give me? Well, that's going to give me 133 over 800. Great, so what do we now need to do? So remember, we have this variance formula that says it's the expectation of the squares minus the square of the expectations. So it's going to be 133 over 800 minus what we've just worked out, so that's 7 over 20 squared. Now, don't forget, it's a show that question previously, so you should use what you're given in the question. Okay, otherwise you get told off and you don't get any marks. So that's going to give me the 7 over 160. So how are the 4 marks allocated here? So you get a method mark for using the formula. You get an accuracy mark for getting 133 over 800 or equivalent. You then get a lesser method mark for using the variance formulae, and of course your accuracy mark here, you've kind of got to get everything right because it's a show that. Okay, so part C, we've got a slightly different random variable this time. Okay, and we're asked to calculate the probability of y being less than 20. So y is defined as being 40 over x. So again, my advice with this, I'm just going to put it at the top, is to recreate yourself a table. It's really the only way of doing these, I think, quickly anyway. So, what can y be? Well, y could be 40, if you're dividing by 1, if you're dividing by 2, if you're dividing by 3, if you're dividing by 4, and if you're dividing by 5. Okay? And these correspond to x values of 1, 2, 3, 4, and 5. I'll just put those up there for now as well. So the probabilities correspond as well. 40, 40, 40, 40, and out of 40. So we're working for the probability that y is less than 20. Well, that's going to be the same as the probability of x equaling 3, 4, or 5. That's actually all we need to do with these. So for part 1, actually, we've got quite a nice task. It's just going to be 9 on 40, plus 12 on 40, plus 10 on 40. Okay, be careful not to include 20 when you're doing these, because that's incorrect. Okay, so you get 3 marks for this. Okay, you get 1 mark effectively for recognising which probabilities it is we need to do. You get an accuracy mark for then adding those together, and an accuracy mark for getting the correct answer. Okay, so for part 2, we've got this idea of a conditional probability again. So the probability that x is less than 4, given that x is less than 20. So the probability that x is less than 4 is going to be the probability of x being 3 and 4 only. So this is the probability of x equaling 3 or x equals 4 out of all of the probabilities that we've just calculated, so 31 out of 40. So if we work this out, probability of getting a 3 and a 4 is going to be your 21. Sorry, less than 4. So let's stitch that, my bad. So that's 9 out of 40 divided by 31 out of 40. So that's going to simplify to 9 over 31. Okay, and that's what's required. So we're going to get a B1 mark for recognising that you're dealing with 9 over 40. You're then going to get a method mark for setting up the fraction correctly, and then an accuracy mark for 9 over 31.